channel. If you have not subscribed to my channel yet, go ahead and click the subscribe button right now before you forget. Now, this is Simplifying Rational Expressions Part 2. If you have not watched the Part 1 of this series, go ahead and watch that video that is going to pop right now on the top. And then come back to this video and let's work through some examples, okay? Now, let's start with a definition, okay? A rational expression is an expression that can be written in the form P divided by Q, where P and Q are polynomials. And check this out, Q cannot be equal to 0. That means that the denominator, this value down here, okay, that value down there, cannot be equal to 0. All right, let's go ahead and jump into some examples. I'm going to do my best to explain to you how to simplify these expressions, these rational expressions. Let's start with the first one. We have, I'm just going to rewrite it, negative 27 times x to the power of 3 times y divided by 9x to the power of 4 times y. Now, there's a way that we can do this. We can use laws of exponents, but that is not what we're going to do this time. What we're going to do is we're going to shift it a little bit and we're going to think about factoring, okay? We're going to factor. And what are we going to factor? Well, we're going to factor the numerator and the denominator. Now, this is what I want you to think about now. I want you to think about what is the greatest common factor, the GCF, of negative 27 and 9. And I'm going to take a little bit of time doing this for those of you who struggle a little bit more with math. So let's think about what will be the greatest common factor of negative 27 and 9, okay? And I'm actually going to, let me just rewrite this, negative 27 and 9, and I'm going to write down my answer here. So what will be the greatest common factor between negative 27 and 9? Let's think about the factors first, okay? So we have 1 times negative 27, 3 times negative 9, we have negative 1 times negative 27, and negative 3 times positive 9. I think those are all the factors. Now, what about for 9? Well, we have 1 times 9, we have 3 times 3, and that's pretty much it. Then they repeat after that. Now, what is the greatest common factor that they have? Well, if you said, well, the greatest common factor is, in fact, positive 9. I see a 9 here, I see a 9 there, and that is the greatest factor. So you are exactly right. So we're going to factor out, okay? We're going to factor out a 9 on the numerator and then end on the denominator, okay? We're going to factor that out. Now, if I factor out a 9 from this negative 27, what am I left with on top? Okay, what am I left with on top? Well, I'm left with a negative 3. Negative 3 times 9 is negative 27. And positive 1 times 9 is positive 9. Now, let's think about the other part like this, okay? I'm going to rewrite this x to the power of 3 as x times x times x. And, well, y to the power of 1 is just y. And this x to the power of 4 is x times x times x times x. And y to the power of 1 is just 1. Now, let's think about factoring the same number of x's from the numerator and the same number of x's from the denominator. How many x's do I have in common? Okay, how many x's do I have in common? If you said, well, we have 3x's or x to the power of 3 in common, okay? Well, you're exactly right. So I'm going to factor out that x to the power of 3 on the numerator and x to the power of 3 on the denominator. Now, what happened Okay, if I factor out x to the power of 3 on the numerator, I am left with no x's. Okay, but if I factor x to the power of 3 from the denominator, I am left with an x to the first power. Okay, I am left with this x here. Now, let's see. How many y's can I factor out? How many y's do I have in common? Well, I have only one y, okay, or y to the power of 1. I only have y to the power of 1 in common. So if I factor that y to the power of 1 from both the numerator and the denominator, what am I left with? Okay, how many y's am I left on the numerator or the denominator? Well, none, because I factor them out. Okay, and 1 times y is y, 1 times y is also y. So my answer for this particular problem will be negative 3. Oh, let me rewrite that. Negative 3 divided by x, and we are done with that problem. Now for this next problem, I'm going to use the exact same method. I'm just going to work a little bit faster. So let me just rewrite it. I'm going to rewrite it here. We have negative 45 x to the power of 6 y to the power of 4 divided by 15 x to the power of 7 y to the power of 4. So I'm just going to write down this negative 45, 15, and I'm going to do x times x times x times x times x. 1, 2, 3, 4, 5, 6. Oh, this is going to be very long. And 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4. Now the questions are the same. What is the greatest common factor of negative 45 and 15? You can do this yourself, but actually I'm just gonna give you what the greatest common factor is. The greatest, how can I say it? One of the multiples here will be negative 3 times 15. And well, here, one of the multiples is 1 times 15. And you will find that 15 is in fact your greatest common factor. Okay? Now, the next step for this will be to identify how many x's you can factor out from the top and the bottom. How many x's can you factor out from the numerator and the denominator? Well, I have 1, 2, 3, 4, 5, 6. It seems that the maximum number that I can factor out from the top is 6. And let's see, do I have enough to factor out from the denominator? 1, 2, 3, 4, 5, 6. Okay, so I have 6 here. I have 6 here. So if I factor x to the power of 6 and x to the power of 6, I am left, let me write this down. Oh, I forgot to say. Well, if I factor out a negative 15, if I factor out a positive 15, that will be negative 3 times 15 is negative 44. And well, 1 times 15 is positive 15. Okay, so I can write down a positive 1 here. So now going back to the x's, if I factor x to the power of 6 on the numerator and x to the power of 6 from the denominator, I am left with x to the first power on the denominator. Now let's see y's. How many y's can I factor out? Well, I can factor out y to the power of 4, and same on the denominator, y to the power of 4. Well, now because I factor the same number of y's on the denominator and numerator, well, I just get a times 1, so times 1 times 1. And that's actually the same thing for the x's. Oh, well, actually not for the x's. At least on the top it is. So it will look something like this. The greatest common factor will be a 1 when you factor out these y's. So negative 3 times 1 times 1, that's negative 3. 1 times x times 1 is just x. And that is my answer. It turns out to be the exact same thing. So Hopefully you enjoyed this video. You can always go back and review the notes. Make sure that you write this down, because what you're going to be doing next is some practice problems.